Hello guys, so welcome to part 3 of PHY101 Rema. Okay, so in this part I'll be solving questions from questions related to chapter 5, chapter 6 as well as chapter 7. Okay, so now let's start with the very first question. They said a car of mass 2500 moving with a constant speed. Okay, a car 2500 moving with a constant speed of 120 kilometer per hour. Okay, so overtook a truck 38,000 kg or speed of 40 kilometer per hour. What is their net force? Okay, so in this question, they're asking us to calculate that. They're asking us to look for the net force of this car and this truck, okay, of the car and the truck, okay. And remember, both of these vehicles, they are moving with a constant speed. The car is moving with a constant speed of 120 kilometer per hour, while the truck is moving the constant speed of 40 kilometer per hour. So what will be the answer? The answer will be what? The answer will be A, which is 0, okay, because we're looking for their net force, right? Yes, since they are moving with a constant speed, therefore they have no acceleration. If there is no acceleration, therefore there is no force. So that is why the force is 0, okay, because why they are moving with a constant speed. Constant speed means no acceleration. Okay, yes. Now let's move to the next part, which is question 2. They say a particle of mass 5 kg is placed on a smooth plane. Okay, so let's say this is the plane. All right, so I say a particle of mass 5 kg. Now this is the particle. Okay, it has a mass of 5 kg. It's placed on a smooth plane whose height is 4 meter. Okay, so the height of this plane is 4 meter. Okay, and length 20 meters. So the length of this plane is what? The length of the plane is 20 meter. Okay, so let me just write it somewhere. All right, so the height of the plane is 4, then the length of the plane is 20. Okay, yes. Now they said, okay, the particle is connected by a light string passing over a pulley. Okay, so let's say this is the light string, then this is the pulley. Okay, the particle is connected by a light string passing over a pulley at the top of a plane to a mass 3 kg hanging freely. Okay, so this is the mass 3 kg that is hanging freely. All right, so the mass, okay, passing through over a pulley at the top of the plane to a mass 3 kg hanging freely. Now that's not to find the common acceleration. Okay, so this question is coming out from a mass connected to another mass. A mass in an inclined plane connected to another mass that is hanging freely. Okay, yeah. So this is one of the applications of Newton's laws of motion. Okay, now they're asking us to look for the common acceleration of these two masses. Okay, so how we're going to do this is very easy. Now take note that when an object is on an inclined plane, just take note that there is one force exactly that's parallel to the plane, and that force is known as I think the parallel component of the weight. Okay, yes, the parallel component of the weight, which is W sine theta. Okay, since we are dealing with, let's call this is mass 1, then this is mass 2. Okay, so since we are dealing with mass 1, that force which is parallel to the plane is known as m1g sine theta. Okay, yes, m1g sine theta. We can say w1 sine theta. Okay, yes. So normally when an object is on an inclined plane, there is this downward force. Yeah, there's this force that is parallel to the plane, and this force is known as the parallel component of the weight. Okay, yes, and this force is known as W1 sine theta. Okay, yes. So take note that when an object is usually on a plane, there is this force that tends to bring the object downwards, and this force is known as the parallel weight component. Okay, or you can say the parallel component of the weight. Okay, yes, there's still another force that is acting perpendicular. That one is known as the perpendicular component of the weight. Okay, yes. So now apart from that one, normally there's a tension that is usually at here, there's still another tension that is usually at here. Okay, so I want to teach you guys how to derive the formula that we're going to use to solve the question. Okay, but in the sake of time, let me just give you guys the formula direct. Okay, yes. So this formula, whenever they ask you to calculate for the common acceleration of a when they ask you to calculate for a common acceleration of two masses, when one of them is really inclined, when one of them is on an inclined plane and the other one is angry freely, and both of them are connected, the formula you are going to use is to calculate for that common acceleration is A is equals to, okay, let me write it here, or okay, let me clean this part. So the formula you are going to use when you come across all these things is, for the common acceleration, is A is equals to m2g minus m1g sine theta divided by m1 plus m2. Okay, so this is the formula. Okay, so this is the formula to calculate for. This is formula to calculate for the weight. I mean, this is formula to calculate for that common acceleration. Okay, yes. So now let's continue. Now, if you look at the question very well, you find out that they gave us this mass this is m2, right? Yes, this is mass 2, then this is mass 1, right? Yes, so there's mass 2, there's mass 1. Now what about the angle? There's no angle in the question, right? Yes. Now let's solve. Let's solve. So A will be equals to what? The m2 is what? If you read the question, this m1 is what? Is 5, right? Yes, m1 is 5. Then m2 is what? m2 is 3 kg, right? m1 is 5 kg, m2 is 3 kg. Okay, now what about, we all know that g is what? G is 9.8, right? Yes, 9.8 or 10, right? Yes, now what about the angle? Okay, because we need the angle to look at the common acceleration. So what about the angle? So now they gave us the angle indirectly. They told us that, if you look at it, they told us that, they said it's placed on a smooth plane whose height, they told us that the height of the plane is 4 and the length is what? 20 meters, right? Yes. Remember, we don't know the angle, right? Remember, from SOHCAHTOA, we know that SOHCAHTOA, right? So means sin theta is equals to opposite over what? Over hypotenuse, right? Yes. Now this sin theta we all know, which is equals to opposite over hypotenuse. Sin theta, this opposite is known as the length of the. No, I'm coming. The opposite, because if we draw it earlier, let me draw it again. Let me draw the inclined plane. Okay, let me draw the plane. Okay, so this is the plane, right? So this is the length of the plane. Okay, the length of the plane is known as, it's said to be 20 meters. Then the height of the plane is said to be what? It's to be 4 meters, right? Yes. Now we know that sin theta is equals to what? We know that from SOHCAHTOA, we know that sin theta is equals to opposite over what? Hypotenuse, right? Yes. Now if we relate it to this place, sin theta will be equals to what? Opposite will be what? When opposite will be 4, right? So normally this is the angle is supposed to be here, right? So this is opposite, right? Yes. So opposite is what? Opposite is 4, then hypotenuse is what? Is 20, right? Yes. So let's say that sin theta is equals to what? 4 over what? 20, right? If we continue further, 4 divide 20 will be what? 4 divide 20 will be, I'm coming. So I'm coming. Okay. So 4 divide 20 will be 0.2, right? Yes. So it will be 0.2. So therefore sin theta is 0.2. So wherever we see sin theta, we'll put 0.2 there, right? Yes. So sin theta will be what? 0. I'm coming. So let me just continue. Let's continue. So sin theta will be what? 0.2. Now just take note that in most questions, and they will not give like this. Most questions they'll give you the angle directly. They will say theta is equals to 30 degrees. So you just need to solve directly, right? Yes. But if you look at this question, they didn't give us that they didn't give us the angle directly. They gave us indirectly. They told us that the length of the plane is 20 and the height is 4. So we now know that our sin theta is equals to what? 0.2, right? So now let's continue. Our M2 is what? Our M2 is 3 times G is what? G is 9.8, right? Yes, minus M1. Let me start on this side. Okay, so A is equals to M2 is what? M2 is 3, right? G is what? G is 9.8. Then minus M1 is 5. Then G is what? We know that G is 9.8. Then sin theta is what? Sin theta is 0.2, right? So times 0.2 divided by M1 is M1 is 5 plus M2 is 3, right? Yes. So if we do it, let me just do everything straight with my calculator. Okay, so let me just do everything straight. So 3 times 9.8, then minus 5 times 9.8, then times 0.2, then divide by 5 plus 3 is 8, right? Divided by 8. So the answer is 2.45 meter per second. Okay, so our answer is what? 2.45. Okay, if you check the option, there is no 2.45. There will only have this. The closest is 2.5. So if you approximate to be what? To be 2.5 meter per second. So the answer is B, 2.5 meter per second. Okay, yes. So just take note that. Let me just tell you guys. Let me just give you guys. Let me just tell you guys something. Okay. So let me give you guys important formula under application of Newton law. Okay. So like the question you just did, Nana, when they say a mass in an inclined plane is connected to another mass suspended freely, and they tell you to calculate for the common acceleration, the formula we are going to use is A is equals to M2G minus M1G sin theta divided by what? M1 plus M2. Okay, yeah, so this is the formula you're going to use when they say when one of the masses is on an inclined plane, the other one is suspended freely. Okay, now when the two masses are suspended freely in a pulley and they are connected together by a light string in a pulley, something like this. When they say, for example, when the two masses are both suspended and they are connected by a light string that passes through over a pulley, when they tell you to calculate their common acceleration, the formula to use will be what? Just remove you see almost like this, remove the sin theta. So A will be equals to what? M2 minus M1 divided by M1 plus M2 bracket close times so G, right? Yes. So this is the formula to calculate for common acceleration when the two masses, when they are connected over, when the two masses are suspended freely, then another one, an air track glider, something like this. Okay, that is in an air track glider. An air track glider is something like this. Okay, an air track glider is something like this. Okay, one of the mass is also in a plane, in a horizontal plane. The other mass is suspended. The other one is what? Is on a plane. Now, when they tell you to calculate the common acceleration, it's very easy. The common acceleration is A is equals to M2 divided by what? M1 plus M2 multiplied by G. Okay, yes. So it's very, very easy. Okay, yes. Now let's go to before let me continue. Now, in this type of scenario, if they ask you to calculate for the total force of the total forces of the total force of the two mass, you know that the total force of the two mass will be equals to usually equals to root 2 of their tension. Okay, yes. But in this scenario, when the two bodies like when they are suspended freely, if they ask you to calculate for the total force will be equals to what? Which will just be equals to 2 of their tension. Okay, yes. So for two bodies that are connected over by light string over a pulley, and both of them are suspended freely, the formula to calculate for their force, total force acting on those masses is usually equals to 2 of their tension. Okay, yes. Now for an air track glider, to calculate for the total force acting on the two masses, the formula is usually equals to what? Root 2 of their tension. Okay, yes. So that is just it. Now let's continue with the next questions. Okay, so the next question, they said a racing car travels around the circular racetrack with a constant speed of 100 kilometer per hour. So the speed, or let me just say the velocity is what? Is 100 kilometer per hour, right? Yes. What is the radius of the circular racetrack if the magnitude of each centripetal acceleration is what? Is 7.72. So this question comes out from circular motion, right? Yes. So this is the velocity, then this is the centripetal acceleration. There's the centripetal acceleration in front of what? 7.72 meter per second square, right? Yes, they're asking us to look for the radius. Okay, so they're asking us to look for the radius of let's say, okay, raising a racing car travels around a circular racetrack with a constant speed of 100 kilometers per hour. What is the radius of the circular racetrack if the magnitude of its centripetal acceleration is 7.72 meters per second square? So this is very easy. So the formula we're going to use to solve this type of question is, remember, centripetal acceleration. This formula for centripetal, we all know that centripetal acceleration is what? It's because of v squared divided by arrow, right? Yes. So we're looking for the radius. Okay, so our acceleration is what? 7.72, right? Then look, this is our velocity, right? Our velocity is in kilometer per hour. So we need to convert it to meter per seconds. Okay, so how are we going to do that? It's very easy. Okay, so let's convert this on from 100 kilometer per hour to meter per seconds. Okay, 100 kilometer per hour. Okay, yes. So remember, this is something as what? This is something as 100 kilometer dividing this is something as 100 kilometer dividing 1 hour, right? Yes. Now remember that 1 kilometer is equals to 1,000 meter, right? Yes. So kilo is 1,000. So we all do like this. 1,000 times 100 will give us 100,000, right? So it's 100,000 meter. Now 1 hour, 1 hour is something as what? 3,600 seconds, right? Yes, very important. 1 hour is equals to 3,600 seconds. Okay, so 1 hour is something as 3,600 seconds. Then 100 kilometer is something as what? 100,000 meter. Because why? If you look at 100 kilo means what? Kilo means 1,000, right? Yes. So don't forget the meter. So 100,000, right? Yes. So 100,000 divided 3,600. 100,000 divided 3,600. Okay, so 100,000 divided 3,600 will give us 27.77. Okay, yes. So our velocity in meter per second is what? Is 27.7777. So approximate 27.778. Okay, yes. And let's continue. So our acceleration is 7.72, then the velocity is what? Velocity is 27.778. Remember all square, right? We're looking for radius, so it's very easy cross multiply. Here now be 7.72 times radius will give us 7.72 arrow, right? Then this, now let's look for the square. The square of 27.778 is 771.62. Okay, so the square of this guy will be is 771.6 62, right? Yes. So what I'm going to do next is we are looking for arrow, right? We have both side by 7.72. Okay, by 7.72. This one will cancel this. So radius will not be what? So let's just do it. Okay, so let's do it. So 771.62 divide 7.72. Our answer will be 99.95. So the radius is what? Is 99.95, which is approximately 100 meter. Okay, so the answer is what? B, 100 meters. So it's very, very easy. Okay, now let's move to the next question. Okay, so next question, which question 4? I said a communication satellite. So this one is for gravitation. Okay, this third question is from circular motion. Okay, yes, these first two questions, they are from force. Okay, now look at this fourth question. It said a communication satellite in a circular orbit moves around the Earth. Okay, so I can clean this part. Let me use this part. All right, so come. All right, they said a communication satellite in a circular orbit moves around the Earth. So let's say this is the Earth. Okay, now let's say this is satellite. All right. Okay, moves around. Okay, it's very far. Okay, now this is the Earth. All right. So now this is the Earth generally. So this is the Earth. Then this is the satellite. All right. Yes. Remember, this is the center of the Earth, right? Yes. So from the center of the Earth to the surface of the Earth, this is the radius, is known as the radius of the Earth, right? Yes. Remember, the radius of the Earth, this is very important, though. The radius, take note that the radius of the Earth is what? Is 6.4 times 10 raised by what? Times 10 raised by power 6 meter. This is very important, okay? Then the mass of the Earth, this is very important. Take note of this. The mass of the Earth is 5.98 times 10 raised by power 24 kg. Okay, so this is the mass of the Earth, okay? Yeah, this is very, very important. Please take note of this. Radius, we all know that from here to here, the radius of the Earth is 6.4 times 10 raised to power 6.4 times 10 raised to power 6 meter. Then the mass of the Earth is 5.98 times 10 raised to power 24 kg, right? Yes, and look at the question. They say a communication satellite in a circular orbit. Okay, so this is satellite. This is satellite. Now, the satellite is in a circular orbit, right? Yes. Okay, in a circular orbit, moves around the Earth at an altitude of 5 times 10 raised to the power 2 kilometer. Okay, so the altitude, the altitude is what? The altitude from the Earth's surface to the altitude. What is the altitude? The altitude is from the surface of the Earth to that distance from the surface of the Earth to the satellite. It's known as what? It's known as the altitude, right? Yes. So they are telling us that from the surface of the Earth to the satellite, the distance is what? Is 5,000. Is 5 times 10 to the 2 kilometer. Okay. Yes. So the altitude is what? The altitude is 5 times 10 raised to the power 2 kilometer. Remember, it's kilometer, right? Yes. So that is very far. Okay. Now this from the center of the Earth to the surface of the Earth, that distance from the center of the Earth to the surface of the Earth is known as radius of the Earth, right? Yes. And radius of the Earth is what? Is 6.4 times 10 raised to the power 6, right? Yes. Now let's continue. They said the satellite makes one revolution every 90 minutes. Okay. What is the centripetal acceleration? It's very easy. The same thing we did just now. Okay. Remember, it's very easy. Okay. Now before I continue, now take on that we all know that from the center of the Earth to the surface of the Earth, normally a normal cycle. Where is radius? Radius is from and that distance from the center of the Earth to the I think to the circumference, right? Yes. From the center of the Earth to the circumference, that's known as radius, right? Yes. So from the center of the Earth, from the center, I mean, the radius from the center of the circle to the circumference, right? Yes. Now, the radius of the Earth is from the center of the Earth towards that distance from the center of the Earth, because it's at the center of the Earth, that is where the mass of the Earth is concentrated. So the distance from the center of the Earth to the surface of the Earth, that distance is known as what? The radius of the Earth, right? Yes. And it's found to be what? 6.4 times 10 to the 6 meter. Then from the surface of the Earth to that distance from the surface of the Earth to the satellite itself is known as altitude, right? Yes. Now the total what will not be the total distance from the center of the Earth to the satellite? The total distance will not be from where? From the total distance from the center of the Earth to the satellite. To the satellite will be what? The total distance will be what? So the total distance will be what? Will be the radius of the Earth plus what? The altitude of that satellite, right? Yes. So that is it. So the total distance from the center of the Earth to the satellite is what? Is the radius of the Earth plus the altitude, right? Yes. So now what is the radius of the Earth? The radius of the Earth is what? Now before then, so just taking that the total distance from the center of the Earth to the satellite usually equals the radius of the Earth plus that altitude, right? Yes. Now let's go back to the question. I said, what is the centripetal acceleration? It's very easy. Centripetal acceleration is usually equals to what? V square over r rho, or it's equals to W square r rho. Okay. Yes. So the centripetal acceleration is equals to V square over r rho, right? Yes. Now let's continue. We are looking for the centripetal acceleration, right? They gave us and they gave us they gave us the radius of they didn't give us, they only give us the altitude of they only give us the altitude of the satellite, right? Yes. Did they give us velocity? No. Okay, they didn't give us velocity. Okay, yes. Now take note that this is very important. Okay, remember that I said the satellite, okay, they say computer satellite in a circular orbit moves around the earth, right? Moves around the earth. That is in a circular path, right? Yes, in a circular path. Now let's look for the velocity first. Before once we get our velocity divided by our radius, we get our centripetal acceleration, right? Yes. Now let's continue. Let's look at the velocity. Now we all know that velocity is equal to what? We all know that velocity is equal to distance over time, right? Yes. Yeah, it can be velocity can be distance over time. Yeah, velocity is distance over time, right? Yes, or displacement over time, right? Yes. Now let's continue. Now velocity is equal to distance over time, right? Yes. Now if you observe, the satellite moves around this earth in a circular orbit, right? In a circular orbit. Now what is total now distance? What is distance of a circle? Distance of a circle is what? Is 2 pi r. Right? Here is very important. The distance of a circle is 2 pi r. I understand because why is the satellite moves around a circular orbit, right? Yes, so the distance of a circle, or it's the distance of circumference of a circle is what? Is 2 pi r, right? Yes. We know that V is equal to D over T. So D, which is the distance of a circle, is equal to what? 2 pi r, right? Yes. Now let's continue. Okay, so if we put this thing, we take it to here. If we take it to here, we'll now have something like this. A will be equals to what? Everything will be what? Everything will be okay, will be 2 pi arrow, 2 pi arrow. Then okay, let me just I'm coming. Okay, everything will be what? 2 pi arrow. Then divide by t. Then don't forget about this arrow, right? Yes. Or before then, or before then, or before then, since velocity is square, right? Since velocity is square, since velocity is square, so everything here will be squared, right? So everything here will be what? Everything here will be the square of 2 is 4. Then the square of pi will be pi square. Then the square of radius will be arrow square. Then the square of time will be what? T square, right? Yes. So in the place of v square, we'll put all these ones here, right? Yes. So I will put everything in place of v square, put 4 pi square arrow square divided by t square, right? So in place of v, we'll put what? We'll put 4 pi square arrow square divided by what? T square. Don't forget about that arrow. Don't forget about the arrow. Remember, V A is equal to V square over arrow, right? So don't forget about this arrow, okay? So let's continue. So our acceleration is now what? 4 pi square arrow square divided by T square arrow, right? Yes. Now what are we going to do next? Okay, we cancel. This one will cancel this. We'll be left with one arrow, right? Yes. So therefore, acceleration will be equal to what? 4 pi square arrow divided by T square, right? Yes. Okay. So one of the arrow cancel the arrow cancel one of the arrows, so many one arrow, right? Yes. Now let's continue. It will be equal to what? 4 times pi is what? 3.142, right? So all squared then times. Now let's go back to this place. And let's go back to this place. Remember, I told you guys that the distance from the center of the earth to the satellite, distance from the center of the earth to the satellite is known as what? Is known as arrow, which is equal to this, which is equal to the radius of the earth plus what? The altitude, right? Remember, the distance from the center of the earth to the surface of the earth is known as radius of the earth. Then from the surface of the earth to this, that distance from the surface of the earth to the satellite is known as altitude, right? Yes. Now the total distance from the center of the earth to the satellite is known as what? Arrow, and is equals to what? The radius of the earth, then plus the altitude, right? Yes. Now what is the radius of the earth? I told you the radius of the earth is what? Is 6.4 times 10 raised to the power 6, right? Then plus the altitude of the satellite is what? 5 times 10 raised to the power 2. Now don't forget that there's a kilometer here, right? Yes, kilo is what? Is 1,000, right? Yes, or is 1,000, right? Yes, or 10 raised to the power 3, right? Yes. So we need to make this, convert it to, we need to, because since it's kilometer, I need to convert it to meter, right? So the kilo is means what? 1000 or 10 raised power 3, right? So times 10 raised power 3, right? Yes. So if we do everything, we add everything, and our arrow will be what? Let's add everything, okay? Yes. Hope you guys understand this place. So the altitude of the satellite is what? Is 5 times 10 raised power 2 kilometer, right? Yes. So we want to convert it to meter. Not going to meter, from kilometer to meter. Well, now to convert it is very easy. Kilo is what? Is 1000, right? So times it to 1000. Okay, yes, 1000, or times it to 10 raised power 3. 1000 is something as 10 raised power 3, right? So if you times this 2, 10 times 10 raised power 2 times 10 raised power 3, according to indices, if you look at it, 10 raised power 2 times 10 raised power 3, we take one of the base, right? We add their power, right? Yes, so if we take one of the base, which is 10, then we add their power, right? So everything will be what? 5 times 10 raised power what? 5, right? Yes. So let's continue. So let's just add everything directly with calculator. Okay, so no, there's no time. Let's add everything. So 4 points, because this arrow here is the distance from the center of the earth to the satellite. Okay, yes. So let's continue. So arrow will be what? 6.4 times 10 raised to power 6.4 times 10 raised to power 6, then plus 5 times 10 raised to power 2. Okay, then times this, which times 10 raised to power 3. Okay, that's all those who don't understand. Okay, so the total distance from the center of the earth to the satellite is um is 69 is 6,900,000. Okay, so our arrow is 6,900,000, right? Yeah, so let's put it here. So 6,900,000, right? Then divided by what? Now our time, look at it. Time, let's say 90 minutes, right? Yes. So let's convert it from 90 minutes. Remember, we want to we use seconds instead of not minutes, right? Yes. So how do you convert from minutes to seconds? You multiply by 60, right? So how do you convert from minutes to seconds? It's very easy. Multiply by 60. So 90 times 60 will give us what? 90 times 60 will give us 90 times 60 is 5,400. Okay, so our time is what? The time is 5,400 seconds. So put it here, 5,400 seconds all square, right? Yeah, so let's do it. Let's do everything. Okay, so let's do everything together. Let's do it. So now be 4 times bracket open 3.142 all squared, then times 6,900,000, then divide by bracket open 5,400. I'm coming 5,000 okay, I'm coming 5 divide by 5,400 all square. So our answer will be 9.34. Okay, so which is A, 9.34. Okay, yes. Now let me just recapitulate. Okay, let me just recapitulate. Now they're asking us to calculate for centripetal acceleration, right? Now, what is formula for centripetal acceleration? There is two formula. A is equals to V square over arrow, or A is equals to W square arrow. Okay, so we'll make use of this one. A is equals to V square over arrow. We can still make use of that one. Okay, yes. Now, they didn't give us the velocity directly. Apart from that one, they said that the satellite will revolve around the circular path, right? Yes. And we want to look for our velocity. Our velocity is what? Distance over time, right? Yes. Now what's the distance? Since the satellite moves in circular orbit, what is the distance of the cycle? Distance of the cycle is what? Is 2 pi r, right? Yes. So divided by t, right? Yes. Since this velocity is square, so square everything here, right? So V is equals to 2 pi r over t, right? Since velocity is square, so we square all these things here. If we square everything, here will be what? Here will now be 4 pi square r square divided by t square. So place it here. If we place it here, everything will now be 4 pi square r square divided by t square. Then that will form that arrow. So this one of the arrow cancel one arrow. Now so that is A equals to 4 pi square r divided by t square. Right? Yes. So the time is 90 minutes. So convert the 90 minutes to seconds. Put it here. 4 we know pi, 4 times we know pi already. They want about our arrow, which is arrow is what? The arrow is what? Arrow is distance from the center of the earth to what? To the satellite, right? Yes. Remember, from the center of the earth to the earth surface is known as the radius of the earth. Then from the earth surface to the satellite is known as altitude. Therefore, distance from the center of the earth to the satellite is what? Is arrow, which is equals to what? Radius of the earth plus what? The altitude, the altitude of the satellite, right? Yes. The radius of the earth is what? Is this. The altitude of the satellite is this. So you add everything, you get how your arrow, place it here, then the time you already get your time. So that is just it, okay? Now let's move to the next question, which is question 5. Okay. So question 5, they said a boy runs along a cycle at an average speed of 12.57 meters per second in 50 seconds. What is its radius? It's very easy. What is its radius? It's very easy, okay? We are looking for what? Radius, okay? They said the boy runs along a cycle, okay? At a speed of velocity is what? 12.57. The time is 50 seconds, right? We're looking for radius. Exactly what we did just now. Okay, so velocity is what? Distance over time, right? Yes. Now, or displacement over time, right? Yes. Now, what is distance of a cycle? Since the boy moving along a cycle, the distance of a cycle, we all know that the distance of a cycle is what? 2 pi r, right? Then divided by what? The time, right? So let's continue. V will be equal to what? 2 pi r divided by t. So 2 times pi is what? 3.142. Okay, we're looking for arrow, right? Yes. Okay, I'm coming. V is equals to 2 pi arrow over t. We're looking for arrow. So let's make arrow subject formula cross multiply. So here will now be 2 pi arrow is equals to Vt, right? Yes. So divide both side by 2 pi to make arrow stand alone. If you divide both side by 2 pi, arrow will be what? Arrow will be Vt divided by what? 2 pi, right? Yes. So Vt divided by what? By 2 pi. So velocity is what? Velocity is what? Is 12.57 times time is 50 seconds, right? 50. Then 2. Well, we all know pi is what? 3.142, right? So let's do it so that we get the radius. Okay. So we get the radius, okay? Yeah, so very easy. Let's do it. So everything will be what? 12.57 times 50. 12.7 times 50 divided by 2 times 3.142. So our answer is 100. Okay, so the answer is A. Okay, yes, 100. So it's very easy, okay? So when they tell you, for example, they tell you to calculate with the velocity of an object when the object moves in circular paths. You also know that the velocity, we all know that velocity is d over t, right? So for a circular path, distance of the circle is what? 2 pi r, right? And divided by this t. So that is just it. Okay, now let's move to the next series of questions. So let's continue with this next series of questions. Okay, these questions they are from chapter 5, chapter 6, and chapter 7. Okay, so let's continue. Now they said question 6, they said find the resistance if a car of mass 521 kg moving at 10 meters per second comes to rest in a distance of 35 meters. Okay, so the mass of the car is 521 kg, right? Then the velocity of the car is 10 meters per second. Then they said find the resistance if a car of mass 521 kg moving at 10 meters per second, which is the velocity, comes to rest in a distance of 35 meters. So the distance is what? 35 meters. What are they telling us to look for? They are telling us to look for the resistance. Now resistance, they say what is it? We find the resistance. Now resistance means force here. Okay. Now let's say when you are driving a vehicle, you apply brake. Brake is a force, right? The resistance force, right? Yes. So they say find the resistance. The resistance here is what they are talking about, force. They are telling us to look for force, which is very easy. What is the formula for force? Formula for force is what? F is equals to ma, right? Yes. Okay. So it's very easy. Our mass is what? Our mass is 521 kg, right? There times the acceleration. Do they give us the acceleration here? No. So we're going to use velocity and distance to look for our acceleration. Remember, there are 3 equations of linear motion. V is equals to u plus at. I'm not going to use this one, okay? Right? V is equals to u plus at, okay? And another one, S equals to ut plus half at square. Okay, we are not going to use this one because why? This one has time. Okay, it also has acceleration, so I'm not going to use it. Then the third one is what? Third one is v square is equals to u square plus 2as. Okay, so the previous one, remember there are three equations of motion, right? V equals to u plus at. The other one, s equals to ut plus half at square, right? Yes, I'm coming. Okay, so s equals to ut plus half at square, right? Yes. Now the reason why we're not going to use this one, v equals to u plus at, is because of time, right? Then this other one, the same reason for this one, because of what? Time. Because we can use, because we are looking for a acceleration. So we are not going to use this one because they didn't give us time in the question. Okay? Yes. But we can also use velocity and distance to look for time. Then we use that time to look for acceleration. Right? It's a long process, so we are not going to use this one. So the one we are going to use is this. Okay? Yes, we want to find our acceleration. Once we get our acceleration, we multiply it with this, we get our resistance, which is the force, right? Yes. So remember, u is always 0, right? Yes. Comes to when a vehicle start or when the body start from rest, u is 0, right? So therefore our v, we have v squared equals to 2as, right? Yes. So what are we going to do next? Okay, so we want to make a subject formula here, right? How are we going to make a subject formula? By dividing both sides by 2 over 2s, right? So a will now be equals to what? Come, let me clean here. A will now be equals to v squared divided 2s, right? Yes, v squared divided 2s, right? Yes. So we can put this one in place of a is equals to v squared over 2s, right? So in the place of a, we put what? V squared over 2s, right? So let me just clean this place. Okay, yeah, right? Yeah, so we know that force is equals to what? Mass times acceleration, right? So in the place of acceleration, we'll put what? We'll put v squared divided 2s, right? Yes. So our force will now be what is equals to mv squared over what? 2s, right? Yes. So that is just it, okay? So we impute the parameters they give to us. So the mass is what? The mass is 521, right? Yes, 521. Then times the velocity they give to us is 10, right? So 10. Remember the velocity here is square, right? Velocity here is square, right? So 10 squared divided by what? 2 times distance is what? Distance is 35. So 2 times 35, right? So if we continue, f will be equals to what? 521 times 100, right? 10 squared is 100 divided by 2 times 35, that is 70, right? Yes. So let me just be fast. Let me use my calculator to do it fast, okay? So let's do it fast. So 521 times 100 divided by 70. So the force is 744. Okay, 744. All right. So if you look at here, the right option is supposed to be this, right? Which is supposed to be this. But in the question, because this question is from past question. But in the question, this was the closest option. Because normally one side is what? 744, right? Yes, but the one here is 74.5. So no option here is correct. Okay, yes, no option here is correct. So you know that one side is what? 744 Newton. Okay, so no option here is correct. So let's continue. All right, so let's continue the next question, which is question 7. Okay, yeah, question 7. Look at question 7. They said a 2000 kg. This one is from chapter 7, energy. Okay, they said a 2000 kg pickup. A 2000 kg pickup truck is moving at a speed of 90 km per hour. How fast does a 10 kg sport car have to be going in order to have the same kinetic energy as a pickup truck? Okay, now let me explain. Okay, let's say this is a truck. Let's say this is a pickup truck, okay? So the pickup truck has a mass of 2000 kg, right? Yes, the pickup truck is moving at what? At the speed of 90 km per hour, right? So let's convert this fast, okay? So let's convert it fast. Let's how to convert from kilometer to meter times by 1000, right? So one could convert this 90. Remember this 90 km per hour. Is this something as what? 90 kilometer dividing by what? Dividing 1 hour, right? Dividing 1 hour, right? Yes. So to convert from kilometer to hour, to convert from kilometer to meter, multiply by 1000. Okay, so let's multiply by what? Multiply by 1000, right? Yes, by 1,000, right? Then we all know that 1 hour is the same thing as well. Let's convert 1 hour to seconds. 1 hour is the same thing as well, 3,600 seconds, right? So there are 3,600 seconds inside 1 hour. Okay, so 1 hour is what? The same is 3,600 seconds, right? So if we do this one, because we want to convert this next kilometer per hour to what? To meter per seconds, right? Yes. So if we do it, 90 times 1,000 divided by 3,600 divided by, I'm coming, divided by, I'm coming. Okay, so 90 times 1,000 divided by 3,600, we have 25. Okay, so 25 meter per seconds. So therefore, the truck, the pickup truck is moving towards with a speed of 25 meter per seconds, right? Yes. So this is not the now this is not the whole question. Okay, now let's continue. The pickup truck, the mass of the pickup truck is 2,000 kg. Then the velocity converted it from kilometer per hour towards meter per second. Right? So the velocity is 25. Now let's continue. They said, how fast does the 1,000 kg sport car have to be going? Okay. So now this is a sport car. Okay. So let's do this sport car. All right. So the mass of the sport car is 1,000 kg. 1,000 kg. Okay. So they said, okay, 1,000 kg sports car. They say how fast? We are looking for the velocity now of this pickup of this guy. We are looking for the velocity. Okay, they say how fast? How fast, which is the velocity, does a 1,000 sports car have to be going in order to have the same kinetic energy as the pickup truck? Okay, so they said how fast will this one go in order to have the same kinetic energy with the pickup truck? Now I may ask, where is the kinetic energy of the pickup truck? Do we know? No. Let's calculate it. So we all know that kinetic energy, formula for kinetic energy is equal to what? Please take note. We all know formula for kinetic energy is equal to what? Half mv square, right? So let's calculate the kinetic energy of the pickup truck. So the mass is what? The mass of the pickup truck is 2,000, right? The velocity is what? 25, right? The square, right? Yes. So let's do it. So half times 2,000 is what? Half times 2,000 give us everything will be 1,000, right? Yes. So let's continue. So 1,000 times the square of 25. So 1,000 times the square of 25 will give us I'm coming with it again. Okay. So 1,000 times 25 square. So the kinetic energy is 625,000. Okay, so the kinetic energy of the pickup truck is 625,000. Okay, so this is the kinetic energy. Okay, joules. Now look at the question. I said, how fast does this sport car have to be going in order to have the same kinetic energy as the pickup truck? Okay, so they're telling us that if this car has the same, if this car has the same kinetic energy as the truck, the kinetic energy of this truck is 625,000, right? Yes. Now they are telling us how fast will this car go if it has the same kinetic energy as what? If it has the same kinetic energy as this truck. So that's saying that the kinetic energy in this question, they are telling us that the kinetic energy of this car is still what? Is still 625,000, right? Yes. Now they are telling us that look at the question. It said, how fast does a 1,000 sports car have to be going in order to have the same kinetic energy as the pickup truck? So the kinetic energy of the pickup truck is 625,000, right? Yes. So they said how fast, okay, if they have the same kinetic energy. So that's that the car have the same kinetic energy with the pickup truck, right? Yes. Now from that kinetic energy, let's get the velocity. I don't know if you understand. They're telling us that how fast will this car go if it's, let me rephrase the question now. Okay, so this one kinetic energy is this, right? Yes. Now they are telling us that how fast will this car go if it's, I'm rephrasing the question now, if it has the same kinetic energy as the truck. So the kinetic energy of the car is what? Is before the what's kinetic energy is equal to what? Half mv square, right? Yes. So the truck, the car, it has kinetic energy with the truck, right? So kinetic energy is what? Is 625,000, right? Yes. That's what look for what they say how fast. We're looking at the velocity, right? Yes, we are looking at velocity. So what's the mass of the pickup truck? The mass is what's the mass of the car? The mass of the car is 1,000, right? Yes, then we don't know the velocity, so that's what we're looking for, right? Yes, half times 1,000 is what? Is 500, right? So 500 times v square give us 500 v square. We're looking for what? V square. We're looking for v. That both side by 500, right? That both side by 500. So this one will cancel this, right? So 625,000 divide 500 to be what? To be 1,250. Okay, so v square is equals to 1,250. Are we done yet? No. We take the square root of both sides. This square will cancel the square root. Then take the square root of 1,250. So square root of 1,250 will give us 35.355. Okay, so our answer is what? 35.355. So this will be the, and this will be the, our answer is 35.355. So if you look at the option, this one, the A is 33, this one is 31, this one is 34, this one is 32. But look at B, B is 35.4. So if I approximate this to be what? 35.4. So the answer is B. Okay, so it's very, very easy. Okay. And let's continue with question 8. So let's continue with question 8. Okay, so let's continue. Coming. Now for question 8, they said two bodies of masses 5 kg and 8 kg are connected by a large string passing over a smooth pulley. Find the common acceleration, right? Yes. So this question, I've given you guys the formula before. Now this question is coming out from it's coming out from when look at it. Two suspended mass, okay? Two masses that are connected over a pulley. Both of the two masses are suspended. Okay, they're asking to calculate the common acceleration. I've given you guys the formula before, so no time to derive. Let me just give you straight the formula. To calculate the common acceleration, the common acceleration is usually equals to what? M2 minus M1 divided by what? M1 plus M2, then multiplied by G. Okay, so let's continue. The first mass is what? M1. The M1 is 5, M2 is 8, right? So let's continue. So let's follow the formula. M2 is what? M2 is 8, right? 8 bracket open minus M1 is 5. Then we all know that G. Okay, we take G to be 9.8 or 10. Okay, then divide by, okay, M1 is 5, then M2 is 8. So if we continue, 8 minus 5 will give us 8 minus 5 is 3, right? So here will be 3. Then 8 plus 5 will give us 13, right? Yes. So 3 times 9.8 divide 13. So 3 times 9.8, then divide 13, give us 2.26. So the acceleration is what? The acceleration is 2.26 or approximately 2.3 meter per second square. So the answer is 2.3, which is what? A. So it's very easy, okay? So for two bodies of masses connected by a string, this is for to calculate for their common acceleration. Okay, it's very easy. Now we continue with the next question, question 9. Okay, so coming now under question 9, look, they said, okay, determine the normal force applied on. Okay, this one let's read the question carefully. Okay, so take note of all these questions that are very, very important. Okay, and please, one thing I will tell you guys, please, if you have not subscribed yet, please do. Okay, yes, support us by subscribing. Okay, now let's continue. Say determine the normal force applied on a 1.5 kg book. Okay, 1.5 kg will pushed against a vertical wall. Okay, now let me illustrate it for you guys. Okay, let's say determine the normal force applied on the 1.5 book. Okay, let's say this is the book. Okay, pushed against a vertical wall. This is a vertical wall. All right. So then, okay, push against a vertical wall. If the minimum coefficient of static friction, coefficient between the book and the wall is 0.6. So coefficient of static friction is 0.6. If the book remains static, okay, we are looking for what? Let me explain. Let's say determine the normal force. Now let's say now this is the force. Now this is the book, right? This is the book. The book. Okay, book. Right? This is a book. Now a force that telling us to look for determine the normal force applied or not on a book pushed against a vertical wall. So this force, we are looking for this force that push this book against this vertical wall. So this is the wall, right? This is the wall. So this is the book. So we have to look for the force that push this book towards this vertical wall, right? They gave us the coefficient of friction. This question is coming out for friction. Because they gave us the coefficient of friction to be 0.6, right? Yes. So we are looking for the force. It's very easy. Now let's analyze it. Let's analyze it. Now there's one thing. Now under friction, you guys know that under friction, yeah, under friction, what is the frictional force? Frictional force is that force that what? So there's usually opposed motion, right? Yes. Now let's say for example, let's say this is a block, for example, and the block is moving towards this side, right? By force is moving towards this side. Frictional force is that force that usually what that opposed motion, right? Yes, it goes opposite to the direction of motion, right? Yes. So this is the direction of this motion of this block. Is this going to this side? The friction will what? The friction will go towards this side, right? Yes. Okay. Now let's look this book, for example. Now let's look at this book. Now this force push the book towards the vertical wall, right? Yes. Now what will be the tendency at which now what will be the direction of this book? Where will it book where will this book likely move to? Because normally, just like I'm holding it's just like I'm holding this duster against this wall. Now on which direction do you think the book with this duster go? Like will it like where will it move? Where will it easily move? As I plan my hand towards this person, where will it easily move? Will it easily move up? No. It will move what? It will easily move downward, right? Yes, look at it. Easily move downward, right? Yes. It cannot move against my hand. Let me understand. Look at it. So it has tendency of moving what? Towards downward, right? Yes. So let's tell you that this book is applied by force to the force push it towards against this wall, right? Yes. So the direction at which this block is, we definitely with this book we definitely move to is this side, right? Yes. Remember, apart from that one, why the weight also has downwards, right? Remember, weight has downwards. So the weight of this book we add downwards. Also enables the body, also enables the book to move in this downward direction, right? Yes. As I apply force on this duster, the weight of this duster is one that usually try to bring duster downward, right? Yes. Same goes for this book, right? Yes. Now, if the book it will move in this direction, where we friction, where will be the direction of friction? Remember, friction always we always go opposite to direction of motion, right? Since motion is like this, therefore friction will be what? Friction will go like this, right? Yes, friction always oppose motion. So the book will move towards this side. The friction will act against motion, right? Yes. So that is it, okay? Now another thing, I told you guys, now previous class, then I told you guys that when an object is on a surface, resting on the surface, there's this upward force, or there's this force that usually acts against this block to prevent the block to collapse, right? This force is known as normal reactional force, right? Yes, normal reactional force, it can be hand, it can be what? It can be arrow, they are the same thing, right? Yes, and normal reactional force is equals to what? Mg, right? Reaction force equals to mg. So it can be hand, it can be arrow, they are the same thing, right? Yes. So normal reactional force always act at the surface, right? Yes. Now where is the surface here? Where is the surface here? Surface here, look at the surface here, right? Yes, normal reaction always act in the surface, right? So normal reaction will act like this, right? Yes. So I can use arrow, I can use hand, right? I can turn this arrow to hand, right? So let me just use arrow, they are the same thing, right? Yes. So normal reaction acts like this, right? Yes. So normally, normal reaction where there is a surface, yes, normal reaction will always act. Yes, normal reaction will always act when there is a surface, right? Always act like this to prevent an object from collapsing. Okay. Let's do this a table now. The normal reactional force. When you apply a book on a table, the weight will go down, normal reaction will go upward, right? Will go upward, preventing the book from to collapse the table, right? Yes, or preventing the block to collapse the table, right? So the normal reaction will act like this, right? Because the exact force that on the surface, right? Yes. So we have something like this now. We are looking for what? We are looking for the force, right? We are looking for the normal force applied that push the book towards the vertical, right? Yes. Now let's do some relation. We all know that friction is equals to what? UR, right? Coefficient of friction times normal reactional force, right? Yes. If let's now normally this is formula for friction, right? Now let's which force are equating each other here. Find out that the weight equals the friction, right? So mg is equals to what? Friction, right? The mention that force again is equating each other. This normal force applied to the book is equating this normal reactional force, right? So normal force equals to arrow, right? Yes. So what are we going to do next? What are we going to do next? Remember, okay, look at it. Weight, which is mg, is equals to fr, right? Yes. But we all know that fr is what? URO, right? For friction is equals to URO, right? So the place of FR put what? URO, right? Yes. Right? Yes. Then don't forget that this normal horizontal force is equals to what? Arrow, right? Yes. So whenever I see arrow, I put F. Or let me not confuse you guys. So let's make arrow subject formula. So the value both side by U. This one will cancel, this one will cancel. So arrow is what? Arrow is equals to mg over U. So whenever I see arrow, I put what? Mg over U here, right? Yes. So F is equals to what? Mg over U. Mg over U. Okay. So let's look for the force now. Mg over U. Okay. Very easy. So let's continue now. What is the mass of the block of the book? Is 1.5, right? So since force is equals to what? Mg over U, right? So the mass of the book is 1.5. Then we all know G is 10. Then what about U? U is 0.6. So let's just do it. We get our answer. All right. So let's do it. So 1.5 times 10. Then divided by 0.6. So the answer is 25. So the force is 25 Newton. The answer is B. Okay. Yes. So let's go to the next question.